Hi, this video is about unpaired electrons in orbitals 2.2. The keywords for this question: which atom have one or more unpaired electrons in a ground state. So it means that it's not excited, not ions. And we're looking at three different elements here: copper, chromium, and zinc. The two concepts that we will have to look at is one, the electron configuration rules, and the second one is how to draw condensed configuration. Well, there are three rules that govern how we draw electron configuration. They are Aufbau principle, you do have to know these names, Hund's rule, and Pauli exclusion principle. Well, Aufbau rules say that electrons will fall into lower energy level before a higher one. So looking at the various n equal 1, 2, 3, 4, n equal 1 have one suborbital, 1s, 2 have 2s, 2p, etc. Well, the way the energy level works is that 1s have lowest, then 2s, then 2p followed by 3s, 3p, and then here's where 4s will be lower energy level than 3d, and then 4p, and then if we have 5s, it'll be up here, etc. So Aufbau is saying is that the electron need to fill 1s, 2s, 2p, 3s, 3p, and then 4s before it's filling 3d. Hund's rule is saying that the electron will fall into the empty orbital of the same energy level before it pair up. What it means is that, let's say we take an energy level of 2p. The 2p level will have 3 orbitals, represented by 3 boxes. Let's say you only have 4 electrons in this 2p orbital, so it's not 4, it's not the 6th electron. The electron will start to fall in the empty orbital first, so you go 1 up, 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 and then the 4th electron will pair up, like so. You will not have the case where 2p4 and the 4 electrons all pair up, leaving an empty orbital. That will not be correct according to Hund's rule. If you fill it in such a way down first, and then 1 up pairing in the middle, that will still be acceptable, as long as you start to fill empty orbital the same way first and then pair up. Last but not least, the Pauli exclusion principle. This just means that if you are in the same orbital, same box, 1 electron had to point up, 1 electron had to point down. If you draw in the same orbital 2 electrons pointing up, that will be incorrect. Going back to our questions, this asks for unpaired electrons, and according to the 3 rules in this, we know that all the lower level will be filled, and therefore there will not be any unfilled unpaired electron. Hence, we can use the condensed configuration to figure out the orbitals in unpaired electron. Another concept we have to look at is how to draw condensed configuration. So to draw condensed configuration, for example, you're trying to find it for zinc. You will notice 2 things. 1 is the atomic number, so it's 30. And 2 is which noble gas come directly before zinc. So in this case, you go 1 period up, the noble gas is argon with 18 proton. Now argon have 18, so 30 minus 18 means you have 12 extra electrons. Now argon here is on period 3. It means that the following will be period 4, energy level 4. So we would know that it will have to continue with 4s, will follow by 3d, etc. There are 12 electrons left. 4s will fill first, so it will be 4s2. That means there's 10 left, so it will be 3d10. So the condensed configuration for zinc is such. If you want to be pretty, you could also rewrite it as with 3d first, following by 4s. Okay, let's see. So copper 29, chromium 27, and zinc 30 for the atomic number. Okay, argon already have 18. 29 minus 18 means 11 left. Chromium 27. 27 minus 18 is 9 remaining. Zinc 30 minus 18, 12 left here. Now the funny thing you have to pay attention to is copper and chromium are 2 exceptions. So instead of 4s2 3d9, copper actually have 4s1 3d10. Chromium, another exception. So instead of 4s2 3d7, chromium being an exception will also have 4s1 3d8. These are just exceptions that you have to memorize. Zinc is not exception. You have 12 electrons left between the 4s and a 3d orbital, and it would be 4s2 3d10. Now you can probably guess that this will have unpaired electron because look, there's only one electron in this orbital. This will not. So your answer is 1 and 2.